So let's take a look at 2i. Inside the brackets, you can see that none of them are like terms, right, Delmar? That's why they're all separated. They're separated. They're 4 different terms. They can't be combined. But it's asking me to multiply, so I'm multiplying this negative 2ax by each one of the pieces in the brackets, okay? So there's no coefficient on this first term except for a 1. So my coefficient will just stay negative 2. I have a, this is exponent 1, and then I have a exponent 3, so I add that to get a exponent 4. There's nothing to combine the x with, so it just gets carried on like that. Okay, so the next term would be negative 2ax times negative 3a squared. Negative 2 times negative 3 is positive 6. I'll have a cubed, and the x just gets carried through again. My third term, negative 2 times 3 is negative 6. I collect my a's. I have a squared now. And I collect my x's. I have x cubed. And then my very last term, a negative 2 times a negative 1 gives me positive 2. I have no a's to collect with, so it just stays as an a. I have 1x here and 3 here. Adding them up together, I get x to the power 4. I think it is. So let's take a look at G. So I have brackets which indicate multiplication, but if I look outside the brackets, there's no number. So if the number is invisible, it just means what, Jordy? If I don't see a number, it's just 1, right? So there would be a 1 here, I guess, and a 1 here, and a 1 here. Okay, so if that helps, 1 times anything just remains whatever you started with. So 1 times C remains C, 1 times D remains D. And once again, 1 times 2C remains 2C, 1 times negative 3D, negative 3D. So it's almost like those brackets were just holding these terms in place. The multiplication didn't affect anything. However, when it's a negative sign changes all the signs inside the brackets because negative 1 times C becomes negative C. A negative times a negative becomes a positive. So the effect that a negative sign, if I erase this again, just a negative sign outside a set of brackets, what happens is the terms inside become their opposite. So the positive C became negative and the negative D became positive. All right, so now I've finished the multiplication. Now I collect like terms as always. So I have 1C plus 2 is 3 minus 1. I'm back down to 2C. And now I'll do my D's. I have a positive 1D and another positive D, so that's 2D. Take away 3D would be minus 2D. So that should be the answer, 2C minus 2D.
Sorry, 3D minus 2D is 2.
So 1 subtract 3 is negative 2. Or hang on, what did I do? Nope, it's minus 1D, right? Thanks, Blanca. D plus D is 2 minus 3 is 1, sorry. So it's 2C minus D. Yeah. Okay, so after multiplication, it's always just collecting like terms, right? So here I have an m, I have to multiply by this binomial. M times m results in
One for M squared.
m squared. Right? I have m times m. Exponent 1, exponent 1. I add the exponents, I get m squared. Okay, m times negative n, well, it just gets written like m times n. There's nothing more I can do with that one. On to the next one, negative n times m. I get another negative. Notice how I write it?
M.
Yeah, you write according to the alphabet. So you follow the order of the alphabet is what I mean. And then I have a negative n. So it's almost like this one. I have a negative n times n. Okay, well, I have two n's, exponent, exponent. A negative times a positive, so it'll be negative n squared. And I've got two like terms here in the middle. So I would have, yeah, m squared. I have a negative 1 and a negative 1. That combines to give me a negative 2.
Can you run through that with me again?
M times m is m squared.
Yeah.
M times negative n is negative mn. N times n is negative mn. We write in the order of the alphabet.
Oh, yeah.
N times n is n squared, but it's a negative n squared. And so these two are like terms. This one? Okay. All right, so there's nothing to do here, right? If there's nothing, if it's a positive sign in front of the brackets, it's just going to get rewritten 2a plus 3. Now I have two monomials to multiply before I do the binomials. So multiply your smaller ones first together, because I have 3 I'm multiplying together, right? A monomial, monomial, binomial. So multiply the same sizes first. That seems to be an easier thing to do. So I have negative 3 times positive 4 gives me negative 12. And it'll be a times a squared. Yes? And I have to do my third multiplication though. So I just multiplied these two, because remember, this is all multiplication. You have to do your multiplication before you do your combining. So these two are just sitting waiting to be combined, 2a plus 3. So I'm going to have to multiply this negative 12a squared by both of these pieces. Negative 12a squared times a will give me negative 12a cubed. And then a negative 12a squared times negative 1 gives me positive 12a squared. Okay, so let's step back. Now we collect like terms. Are there any terms that are like terms in this statement?
12 and 12?
Nope.
Those right?
Nope. If you look back at lesson 1, we defined like terms as they have the exact same variables, exact same exponents. I don't have any terms with exact same variables and exponents. So the only thing left to do is write this in proper order. Negative 12a cubed plus 12a squared plus 2a plus 3. It's like my powers of a are descending, going down, constant at the end.
So if we forgot to write it in the order, we should use marks for that, I guess.
I think I'll be lenient on you for the first little bit. If you get this, then I'll be happy. How do I find the area of a rectangle?
Times width?
Length times width. So if it says find an expression, the most you can do is just say, well, it's 11x times 3x. And what would that simplify to? 33x squared. So that would be the expression for the area of that figure. What about area of, remember what this is? It's 1/2, or it's base times height divided by 2. Okay, so what's this one? 4 times 10 divided by 2. What's the area of this? 20 meters squared. We'll be doing lots more design and measurement later on.
Base times the height,
Yep,
same thing.
yep. Okay, we're a pretty quiet bunch. Let's talk about dividing, and then because I did sort of talk about it on Friday as well, so it is going hand in hand. And then we're done these nitpicky rules, and we'll do some substitution, then we'll solve some equations, which you guys will probably find very rewarding and nice to get into. So now division. If you look back at those rules that we talked about, we did cover division. And because division is the inverse of multiplication, if we're multiplying the same bases, we add the exponents. If we're dividing the same bases, we subtract the exponents. And the reason for that is, let's take a deeper look at this one. I have 8x to the power 7 divided by 4x to the power 4. And it states that the answer is 2x cubed. Well, that could come easily by 8 divided by 4 is 2, and x7 over x4, if I subtract the exponents, I get 3, right? But once again, just to sort of repeat what we talked about on Friday, this really means 8 times 1, 2, 3, 4, 5, 6, 7 x's, right? That's where x to the power 7 or x exponent 7 comes from. It's x multiplied by itself 7 times. And on the bottom, I would have x, 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 x. So I think everyone is comfortable with knowing that 8 divided by 4 is 2. Now, where the x's are concerned, if I have an x divided by an x, like x divided by x is just 1, right? Anything divided by itself is 1. So if I have, whatever I have, if I have 9 divided by 9 is 1, right? 5 divided by 5 equals 1. Negative 3 divided by negative 3 equals 1. Whatever x is, if I divide it by itself, it's equal to 1, right? So all those x over x's just cancel themselves out to 1s, meaning x divided by x is just a 1, and a 1 doesn't change the value of anything, right? X over x is another 1. X over x is another 1. X divided by x cancels to 1. So what am I left with? A 2 times x times x times x, or I would write that as 2x cubed. So that's why when we're dividing the same variable, same base variable, we just subtract the exponents. Now, if we don't have a variable to cancel, there's nothing to cancel these x's out, so they just stay there, right? 15 divided by 3 is, or sorry, divided by 5 is 3. But there's nothing to cancel the x's out, so they stay as x squared. All right? 20 divided by negative 5 is negative 4. M to the power 1, right? But we would just record that as just negative 4m. You won't be marked wrong if you put the little m to the power 1. It's just not traditionally written. So when you look at a textbook, it might look, you might be looking for that exponent 1. It'll never be written. It'll just be written as an m. Okay, it doesn't matter how many variables you have, you go through the same process. Negative This negative sign belongs to the whole fraction, by the way, right? So it's going to be a negative. 100 divided by 25 is 4. X, what power will be on the x? What exponent? 2. What about the y?
4,
And the z?
2.
2. That's it. Okay, what about this next one? Negative 3 over 12. Can you reduce that in any way? Negative 1 over 4, I think. Right? Okay, x to the power 6. What happens if I have y9 over y9? It cancels to 1, right? So I don't have to record that. It'll just be 1. Now, I can write this as negative 1/4 x to the power 6, or it could also be written as, remember these are being multiplied together, so you could look at it and say, I could multiply my 1 times my my x to the power 6. Sorry. And my 4 would go on the bottom. These, I'll just erase this guy right now. Negative 1/4 x to the power 6 is equivalent to negative x6 over 4. These are equivalent. Easy, Jordan? Jordan, yeah? You've done all this before? Okay, are we okay with this? You gotta speak up. Okay, so I'll just finish off these tougher examples then, and if you can try and link these to what you were just working on with multiplying a monomial by a bigger polynomial, we're gonna do the same thing when we're dividing a polynomial, meaning like a binomial. This one's got 4 pieces. We just call it a polynomial. This one's got 2 pieces, a binomial, another trinomial, etc. It doesn't matter how big your polynomial is. You're going to just be dividing them by a monomial. What this means is you have to divide each piece by the denominator. So that's what this really means. When you're dividing, whatever you're dividing out, you're going to end up with, if you've got 2 pieces on the top, your answer is going to consist of 2 pieces, right? So I have 8 divided by 4 is 2. 12 divided by 4 is 3. There's nothing to cancel that x out, so it just gets recorded as 2 plus 3x. Or, if I wanted to write it in proper order, kind of for bonus marks, it would be written as 3x plus 2. Because we always write the constant at the end. I'm not that concerned about that at this stage, to be honest. If you can get this far, that's great. Okay. Would it be okay if I just did my division without showing this intermediate step? Okay, let's try it. 5y divided by negative 5. What would that result in? Negative y, right? Negative 1y or negative y? Okay, so I've done that division. Negative 15 divided by negative 5. Positive 3. Yep. Now that's actually written in proper order. The constants at the end. Now for the next one, you're dividing a 2 out of each piece, right? Think of it that way. So if you're just dividing by 2, you'll have 2x cubed minus 6x squared.
Sorry.
Yeah.
And can the answer still be 3 minus y?
You could, but it wouldn't be written in proper order. So this is actually a better way to write it. The constant's usually written at the end. Negative whoops, sorry,
Now we're back to 3.
yeah. Negative 3x squared plus 2 divided by 2 just becomes 1, but I don't write the 1, right? But 2 divided by 2, I have to write that one because it's not a coefficient, it's a constant. And I just take a quick look, that's written in proper order. Power 3, power 2, power 1, no power. Okay, you try the next one. Try D on your own. Okay, so D is negative m plus 3. Agree or disagree?
What
Agree.
happened to the squared there?
Well, Cliff, we're subtracting the exponents, so on the bottom you have exponent 1. 2 subtract 1 leaves you with 1.
Oh, yeah.
Okay, so the next one, take a sec, give it a try. Okay, so you should get negative 4m squared minus 2, what? M plus 6. Is it written in proper order? Yeah. Okay, so last one, you got lots of variables going on there. Take a few secs, try that one. Okay, so last one, negative 2a cubed b plus 9a squared b squared minus 1, but I'm not going to write my coefficient 1. The a squareds cancel out to ones as well, and I don't write that either, so I'll just be left with a B. Okay, so you guys watched, I recorded this whole thing, right? And I have a feeling it's not coming up on my, I just checked Google again. So the videos aren't coming through for some reason. So for the next couple of days, so we can get straightened
Why
out.
wouldn't it still be a 1B at the end there? Like, wouldn't that, component have to
Like
stay
putting a
there?
1 here?
Yeah.
Yeah, you can. It's just that in math, we never write coefficients of 1. If you write it,
Oh.
it's not wrong, but. Anyway, sorry, it doesn't look like this video is coming through, and I'm hoping it comes later, so there's something going on with this recording. Anyway, okay, so I'm going to assign the division, it's very similar, right? So just get some practice on that. And we'll be finishing up this unit. I thought we might finish by the end of this week, but I don't think we will. So it looks like we'll have a test early next week, maybe Monday.